Now we are discussing about controlled area network, which we are calling as CAN. So this controlled area network, for this protocol, the set of rules are given by ISO 11898. It is a two-wired network protocol. In this, the communication will happen in the half duplex manner. We can send the data from one device to another device, and to the same device may communicate with the source device, but not at the same time. In the half duplex manner, the communication will happen. Here the communication is happening serially, and the communication speed is very higher compared to the all protocols we have discussed, but this will happen only in the low radius. So whenever we want to have some communication between the two devices in automobiles, some autonomous vehicles, some warships, that may be either submarine, that may be either flight, that may be either a fully automated train or any other automobile, where we do not have any external connection, where we don't know how the internet works, where we do not rely on the signal from the satellite, where all the systems connected together want to communicate with each other in that automobile itself, because that automobile will be moving always. Because of the moving of the automobile, as you already learnt in the cellular communication, when the cell is changing, base station is changing, so sometimes we might not get the signal. That's why in the automobiles, sophisticated automobiles, where we have more than one system, where we have multiple systems, we want to communicate from one system to other system in that automobile by using the controlled area network protocol. Here definitely the communication will happen fastly because it is a wired, and we are using a half duplex communication. Here we are making sure that the frame, because we are discussing in the level of the data link layer, the data we are sending in the form of the frames that are sent from device 1, this is device 2, both these devices are set up in the same automobile, because we are saying this will work only in the low radius. That does not mean that we cannot implement for the high radius, but because of the cost effective compared to the remaining protocols may become cost effective when we go for the high radius. This is best protocol in terms of the speed and in terms of the reliability of the frames of data we are sending when we are using in the automobile. So here we are using CSMA-CD. We discussed three types of in the CSMA-CD protocol. Mainly we discussed three types. One is high persistence method, second one is non-persistence method, and the third one is P persistence method. In the high persistence method, we have discussed whenever we want to send the frame of the data, immediately after sending one station, the second station will check for the availability of the bus. If the availability of the bus is there, it will send, or it will immediately again check, or next it will immediately again check. It will do like that. It will not wait. So that's why we are saying sometimes even though there is a free space in the communication channel, when more stations are checking, each station feels that, each station senses that the communication channel is empty. So because each station felt the communication channel is empty, all these stations are sending the frames of the data at a time to the communication channel. That's why there is a chance for the more collision of the frames in the high persistence method. That's why we went for the next non-persistence method, There we are actually waiting for some amount of time. There is no doubt we are reducing the collision with this waiting method. But the problem is, during the time of the wait, the first station might have completed its already transmission by that time. So there is a chance of the wastage of time. In the network bandwidth, in the communication channel, wastage of time, it costs a lot to us. So that's why we are going to the P persistence method, which is giving the advantage of non-persistence method, waiting, and which is giving the advantage of high persistence method, continuously checking. So these both advantages we are combining and we brought the P persistence method. Here we are using CSMA-CD with the, either we can use with the non-persistence method or with the P persistence method. We are giving the priority here. When more than one station is there, example here 5 stations are there, these 5 stations wants to send the data immediately. Definitely, because I am discussing the data link layer, the data is nothing but it is in the form of the frames. So these 5 stations wants to communicate the data in the form of the frames. They are using the same bus. CAN protocol is bus based protocol. So here we are using the bus for the communication. We discussed the different types of the topology: bus topology, star topology, tree topology, mesh topology, hybrid topology. Here we are discussing about the bus. This is a bus based protocol. All these 5 stations wants to send the frames to the same bus. But here we are saying the new word called priority. So this is a priority based protocol. Until now we never discussed any protocol which works on priority. First time we are introducing a protocol which works on priority. Whenever the 5 stations are sending the 5 messages frames, we are giving the priority to a particular message. We are giving a priority to a particular station with some ID number, and we are saying first this message should be transmitted. Definitely the message in the form of the frames only. There is no doubt. Whenever I am saying the message here, because I am discussing in the layer of the network layer, always the message means only the frame. So here we are sending the frames, which message should be communicated first, that will be decided by me by using the priority. We are giving some ID numbers. So because we are sending based on the priority, first station is sending priority completed from source to destination in the half duplex mode. The communication will happen. Next, second priority. Next, third priority. Like this. We are giving the priority in this protocol. So that's why we are making sure that there is no collision. So the advantage of this CAN is, here we can see, we have written here, it is noise-free protocol, and also error, the chance for the collision is very less because we are using the term priority. That's why the communication speed is also high. We are seeing some features. In the features, at a time, multiple masters can use the bus in the half duplex mode. At a time, whenever I am saying at a time, my intention is to say that they can access the bus, but they cannot send the frames on the bus. It is like you are waiting for the bus. You have given the token for to get to a ticket is given to you. You have given ticket, but you have to wait. Based on the priority only, you will be sent to sit in the bus. Similarly, multiple masters can access the bus, but they can send the frames based on the priority only. We have discussed from the starting onwards, it is a priority level protocol. And multiple levels we are detecting the errors. Whenever the station is sending the message, at that time only we are doing the error detection. Each node is acting like a station, and during the transmission only we are checking the error. In this protocol, not even during the transmission, not in the channel we are checking the error. At the time of the transmission, from the source end only when we are sending the data, once we are trying to make sure that it should not, any error should affect the frame, whatever the frames we are sending. And also, Here we are using the separate clocks for the synchronization of the each node, because 5 stations wants to use the bus. First station sent the frames, first station sent the message, and based on the priority, first station message is already communicated. Second station has to transmit its message. Then immediately second station will get the alert, because the synchronization of the clocks, immediately it will send the data. So the waiting time also it will be very less. That's why the communication is very faster. This is one advantage. Okay. Next we have discussed some of the advantages. Here many manufacturers, because automobile manufacturing is nothing but the companies, they will integrate all the different components in the same automobile. The automobile manufacturers, they are making sure that they are manufacturing the physical layer and the data link layer integrated chip. There is no need for us again to check for what we have to do for the data link layer. Already they are giving a physical layer, data link layer, integrated chip. Only we have to develop the program, how this chip has to work. That has to be done by us. That is the advantage. And here this is noise free transmission. Even though we operate in different electrical environments, sometimes you may operate in under water, sometimes you may operate in the air, sometimes you may operate in the deserts, sometimes you may operate in the snow regions, sometimes you may operate in the border regions, sometimes you may operate in the regions where you might not get the signal because you are traveling in the automobile. So in each of these circumstances, even though these electric disturbances are high, sometimes you may get the ionospheric reflections sometimes high, because of the ionospheric reflections may vary from day region to the night region. Because of these all electrical disturbances, this whatever the control area network protocol we have designed, it will not get affected like the remaining protocols. So here the traffic congestion is also, there is no chance for the traffic congestion. We are sending only one data. We are sending only one data, that is based on the priority. And the timing constraint, immediately after sending one frame, immediately after sending one message of the first priority station, immediately we are sending the second priority station message. That's why the timing constraint also, the waiting time is very much less. This is also one of the advantage of the control area network. Error free transmission. Multiple times we are doing the error detection, and error checking is done at the each node. This is the advantage. It is efficient in the terms of each frame we are sending from the source that will be received by the destination, and we are reducing the weight. There is, when we are designing something for the automobile, we always try to reduce the weight because it has to move. We should not design something which is having bulkier weights. Because of the control area network protocol, we are making sure that the wires whichever we require in remaining protocols, a large number of wires are not required here. We are not using any big number of LAN cables where to connect, or even we are not going for the wireless here because we need definitely a faster communication. That's why we are going for the wired. And it is a centralized protocol. For each time, there is no need to depend on different subsystems, substations, centralizedly based on the priority. After one message is sent, next second message we are sending based on the priority. The priority is given in the terms of the ID numbers. This is about the control area network protocol. We are once again revising the important points. Control area network protocol set of rules are given by ISO 11898. The main theme of this control area network protocol is it is designed for the automobiles, where we do not have the ability sometimes to connect to the satellite or maybe nearby the antennas. There the systems want to communicate with each other. The communication should be faster because it is automobile, it is moving, that may be flight sometimes. There we should not, definitely there we should not avoid the chances of the delay. Sometimes if delay happens, that automobile operation may affect, that may be submarine also. Here the controlled area network protocol is very much faster, and we discussed it is depending on the CSMA CD. we are using the term priority. Based on the priority, we are sending the frames from one end to the another end, and the communication is half duplex communication. This is about the control area network protocol.